Hi everyone. We have a function here and we have to answer 4 questions for the AP examination, and you probably have already practiced this in class. We also have to sketch the graph. This particular problem you can use the calculator, but I do want to state before that since our degree of this polynomial is 4, that means it resembles the y equals x to the 4th graph, which just looks like this. So that's going to help you know that when you graph this, you're going to start in quadrant 2 here. If you're reading the graph left to right, it's kind of flat in here, and we're going to end up in quadrant 1. So that kind of helps, makes you feel better when you're graphing this. So we're going to go through all this, find the equation of the tangent line to the graph, and it's going to be at -2, 17. We've got to find the x and y coordinates of the relative or local maximum and relative minimum, and also the x and y coordinates of the points of inflection. So let's get started. We have we need the equation of the line tangent to the graph at this point here. So in order to find the equation of the tangent line, we need to take the derivative of the function. Again, our function is 2x to the 4th minus 4x squared plus 1. So we take do f prime of x, and we get so 2 times 4 is going to be 8x cubed minus 8x. Okay, and then all we have to do is plug in our -2 to find our slope. So you plug in -2 here, and this is going to yield -48. So this equals your m. Now we're going to use the point slope form to get the equation of the line, and then put it in slope intercept form. So basically our point slope form is going to be y minus your y here, and then your slope is -48 times x minus the -2, which is x plus 2. Alright, if you simplify, you're going to get y equals -48x minus 96 plus 17. So that's going to give you your equation of the line, -48x minus 79. Okay? So this question on the AP exam is worth two points, one for finding the slope and one for finding the equation of the line. Now we have to find the x and y coordinates of the relative maximum and minimum. If we want to find the maximum and minimum, we need to take the derivatives and set it to equal to 0. So we've already done that. We've already taken the derivative, here it is, and we just set it to 0. So the derivative, again, was 8x cubed minus 8x, and we set this to 0. So basically, factor out an 8x, and you get x squared minus 8, or 8 squared minus 1 equals 0. So basically we have 8x equals 0, and then we have x squared equals 0, x squared minus 1 equals 0, which is x squared equals 1. So basically we have x equals 0, and if you take the square root, you get x equals plus or minus 1. You square root, be sure to do plus and minus. Alright, so we have 3 x's here, and these are our critical points. In order to see if the point is maximum or minimum, we usually take the second derivative and we plug in each critical point into the second derivative. So let's do that. So our second derivative of this is going to be f double prime of x is going to be 24x squared minus 8. Now we plug in these critical points and see if we can get a relative maximum or minimum. Okay, so plug in 0, and I'm just going to do that. You plug in 0, you get negative 8. Now we plug in 1. You plug in 1, you get 16. Excuse me, if you plug in negative 1, you're going to also get 16. So, since these two are positive, that means these are relative minimums. Remember, if it's positive, it's a minimum because the slope is tending up. After this point, we're going up. And since we have negative 8, that means that that's a relative maximum. Okay, so now we just plug the x values back into the original equation and get the coordinates. So we're going to plug in these 1, 2, 3 points back into our original. So just into the original, plug f of 0, that's just going to equal 1. And this is our original again, f of x equals 2x squared, or 2x to the 4th, minus 4x squared plus 1. Again, this would be your y-intercept on this one. And that's going to be your relative maximum. Then we plug in f of 1. You plug in f of 1, you're going to get negative 1. You just plug it in, and I'm just doing it mentally. And you plug in negative 1, you also get negative 1. So basically our points are going to be 0, 1, which is our y-intercept. This is going to be a relative max. And then plug 1, negative 1 is a relative minimum. And so is negative 1, negative 1. That's going to be a relative minimum. All right. So this part was worth 3 points. Now we have to find the x-coordinates of the points of inflection. So basically, we set the second derivative equal to 0, and then the values that we get for the x-coordinates are the points of inflection. So we already did the second derivative, and the second derivative was 24x squared minus 8 equals 0. So we get x squared equals 8 over 24, which equals 1/3. So when you take the square root of both sides, you get plus or minus square root of 1/3. Or you can write it plus or minus 1 over square root of 3. Now, in order to find the y-coordinates, you plug it back into the original equation. Because remember, we have to graph this. So we have two values here. So let's plug it in to the original equation. So you have f of square root of 1/3. That equals 2 times the square root of 1/3 to the 4th minus 4 times square root of 1/3 squared. And this is going to equal plus 1. Don't forget your plus 1. I'm not going to forget the plus 1. All right. So this is going to equal 2/9 minus 4/3 plus 1. And this is going to equal negative 1/9. Now, do the same for the negative. And this is going to equal 2 times negative Just do the same thing here to the fourth, minus 4. That should have been there. Square root of 1/3, negative 1 squared. Negative square root of 1/3 squared plus 1. And that's going to equal 2/9 minus 4/3 plus 1, which also equals negative 1/9. So the points of inflection are square root of 1/3, comma negative 1/9, and negative square root of 1/3 and negative 1/9 again. So now we have to just graph this, and they say you can use your calculator on this, but let's just look at the graph. And I'll do a little graph here. So basically, my y-intercept was 0, 1. I'll just put the 1 here. And we also have critical points at negative 1. So negative 1, negative 1. So right in here. And also at 1, negative 1. These are relative minimums. Also, from the beginning, we know that we're starting somewhere in quadrant 2 and ending in quadrant 1. And we also have our points of inflection. And so it's really going to be kind of hard to tell that, but 1 over square root of 3 is 0.5. So that's kind of in, let me do half of this, would be right in here. Points of inflection. And then we also have 1. Well, so that's that, and then up a little, because it's 1 over 9 is approximately 1.11. So I'm just going to put these in here, halfway through here. So this was 1. All right, so your graph looks like this. Have a little point inflection where it's changing a little. So it's going up in here, then it's more going like that. It's your point in inflection, so it's going down here. And right at this point, it starts concaving the other way. And then you go back up in here. If you do this in the calculator, you can just set your graphing window to x min equals negative 4 and x max equals 4, and set your y min to equal negative 6 and your y max equal to 6. Okay? And that's it. Thank you. Have a nice day. Bye-bye.